Hi, everyone. We're going to give it about a minute to let people continue joining and we'll get started. Hello, everyone. Thank you so much for being here. On behalf of the Environmental Finance Center Network, welcome to today's webinar on Unlocking Energy Efficiency for Small Wastewater Treatment Plants. My name is Owen Volk from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it in the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in the U.S., states, and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. One of the many ways EFCN can support your community or utility is through our free funding application support. Struggling with an infrastructure funding application, falling short on project funding, not sure where to start? EFCN is here to help. Submit a request through the link in the chat to receive tailored support based on your project needs. And on that note, we can get started today. I would like to introduce our presenter for today, Danish Kumar, Climate Change Program Manager at the University of Maryland Environmental Finance Center. Welcome, Danish. I will go ahead and hand it over to you.
Thank you, Owen, for the wonderful introduction. I hope this I'm audible to everyone and slides are showing correctly to everyone. Owen, can you please let me know if it's okay?
Slides look good.
Okay, perfect. Thank you. So hi, everyone. My name is Danish Kumar. I'm a climate change program manager at Environmental Finance Center, University of Maryland. We work in a lot of similar domains as other EFCs. We have programs on advancing financing solutions. We try to build local capacity and serve communities by education, training, technical assistance, research, policy analysis, financial assessment, and community outreach and facilitations. These are some of our flagship programs: Municipal Online Stormwater Training Center and Sustainable Maryland, which provides certification to Maryland municipalities. As Owen said, if you are in search or need for technical assistance, you can go to ESCN website and click here on Get Help and to get technical assistance or look at other resources that are available on the EFCN website as well. Also, just a outline, we'll start with introduction of why we need energy efficiency for the wastewater treatment plants, some terms with Energy 101 for wastewater treatment plants. We'll talk in detail about energy audit and go in depth into energy efficiency strategies that are commonly used at wastewater treatment plants. I'll show you some success stories and next steps on what to do and some resources. And at that end, we'll have time for hopefully for the question and answer session as well. So energy in wastewater treatment plant. Small systems protect public health and environment, especially in rural areas. And according to 2022 Clean Water Net Needs Survey, they serve nearly 82% of the population. The majority of these systems are small, as we all know, and designed for less than 1 million gallons per day. And we have made a lot of progress in treating our wastewater, which has increased their energy use as well. So energy use of wastewater treatment treatment plants consume 3 to 4% of US electricity, which costs about $2 billion per year. And energy use accounts for 30 to 40% of the total operational and maintenance cost of the facility, which also leads to additional greenhouse gases as well. So where is energy used in small wastewater treatment plants? Energy is used at every stage from collection, pumping, aeration, and solids handling. The energy use of small wastewater treatment plant is 3,000 to 6,000 kilowatt hours, a million gallons per day, which is usually or typically higher than the larger facilities, which are more energy efficient than the smaller facilities. And this high energy consumption can rapidly escalate cost, increase the cost for the your operator or facility provider, and then making utility expenses one of the largest operational burdens for the operators as well. And because this is a critical infrastructure, it has to run almost 24/7 to provide the services to the communities. Time for a poll.
Another 10, 15 seconds. Okay, let's share the results. So for the question of what area do you think consumes the most energy in your plant, about 46% said aeration, 33% said pumping, 5% said lighting and HVAC, 2% said solids handling, and 13% are not sure.
Okay, that's great. I think most of you have hit the right spots. So this is the correct answer. Aeration uses a lot of energy, as well as pumping, lighting, and HVAC, as well as anaerobic digestion. These are the four major energy consumption areas at a wastewater treatment plant. It might look different, but the majority of consumption is divided into these four sectors as well. And so this is why energy matters for small wastewater treatment plants. The requirements for your permits are increasing day by day, and there are advanced treatment needs which require more energy. And then there's also biosolids treatment, which adds complexity as well as increases the energy use or energy needs of the wastewater treatment plant. Aging infrastructure, we all know that most of the infrastructure for the wastewater treatment plants was built in 80s, 70s. So there's a lot of like old infrastructure which needs to be replaced or upgraded and cater to higher volumes. And then electricity rates with increasing demands, the electricity rates are rising day by day, which impacts the operation as well, and as well as impact the budget which usually energy consumes like 30 to 60% of a small system budget, depending again on where you're located. We all have resource challenges. There's limited staff capacity, funding, and technical resources available, and a lot of workforce is set to retire sooner as well. And then this leads to financial sustainability and influent variability, which also come along with the wastewater treatment plants in general. So these are some benefits of energy efficiency. It provides you maintained or improved output or effluent with efficiency upgrades. You can uphold uh, safety standards while reducing energy consumption. You can also meet regulatory compliance, meet those permit requirements through smart controls and monitoring and reduced energy use and save cost, as well as improve your operations, as well as lower the environmental impact and greenhouse gas footprint. Time for another poll.
Okay, just give me 1 second. Okay, we're gonna give it another 15 seconds. Okay. So for the question, what's your biggest challenge when it comes to improving energy efficiency? 38% said lack of funding, 6% said limited staff capacity, 31% said aging infrastructure, a lack of data and monitoring tools at 13%, and not sure where to start is also at 13%.
Okay, that's amazing. I think we are at a right spot, and we'll definitely touch base on almost all of these things, some in detail, some just an overview, and we'll provide you some resources and tools to go with that. We'll just start with energy fundamentals, like what is energy? Energy is capacity to do work. It is measured in kilowatt hours or British thermal units. Then there's power, which is rated, which energy is used, measured in kilowatt hours. And then there is energy use intensity, which is usually the measure of energy efficiency of your site. It is a metric used to express energy consumption of the plant relative to volume of wastewater it treats. And then kilowatt hour, like a 10 kilowatt pump would be running for 5 hours, for example, and it will use 50 kilowatt hours, and you'll be charged for that 50 kilowatt hours in your energy bill. We'll just talk about the energy bill as well in a little bit. And energy use intensity for wastewater treatment plant is either measured usually in kilowatt hour per million gallon per day, or if you want to go with the specific metrics of biochemical oxygen demand, you can do with that as well. It is just to establish a baseline to compare how your energy is being used throughout these year or different months. So we'll just start with understanding your energy bill. First of all, it is really important to go in great detail to your energy bills, understand what you are being charged for, if there are any demand charges, any time of use charges, or any specific charges, and understand what kind of rates you are being charged for. And then it is always great to contact and get to know your energy provider account representative for your facility, because that really helps in determining what rate schedule you are being charged, and is there any possibility to like reassess it or renegotiate it, or if sometimes a lot of utilities have incentives, financial as well as some technical resources available to help you out with reducing your energy charges as well. So connecting with your utility provider is really a good thing to do, and understanding your energy bill is the like first step to start with. And then a lot of utilities are currently charging demand charges from their customers, and demand charges are usually based on maximum power draw during a billing period, not the total energy consumed. So you are not only paying for energy consumed, which is charged in kilowatt hours, but you are being also charged specifically for demand charges, which can vary from month to month. And as the graph shows, it can be a peak demand. So they'll multiply that peak demand with that particular rate, which is often ranges from like $5 to $15 per kilowatt hour per month. And it is usually from the bills I have seen for a utility, it is like almost 30% of the electricity bill as well. So we have to keep that in mind while doing energy efficiency upgrades and improvements. So how to reduce demand charges as well. Efficiency versus conservation, these terms are used interchangeably. Energy efficiency is using less energy to accomplish the same task, and energy conservation is practice of using less energy, for example, turning off lights or reducing the run times of any equipment. So these are for those people who don't know where to start. This is the perfect slide for them, steps to improve energy efficiency. We should always start by assessing current energy use, get to know what we are being charged for, where the energy is being used, and then get together and develop an energy management plan, create a roadmap for improvement, and then identify which equipments require upgrade. For example, old equipment could be replaced at the end of a life with the high efficiency pumps and motors. We can also install VFDs, variable frequency drives, and pair it with SCADA systems so that they go hand in hand together and make it the operations more efficient. And then there could be some operational changes to that plant as well, shifting equipment to off-peak hours or using real-time data for to make decisions. We'll learn more about it in detail in next slides. And then you can also have renewable energy integration like solar or biogas capture and utilization at your plant. So energy audit, this is the really first basic step to know the overall in the overall energy management practice. And it is an official examination and verification of energy accounts to see where energy is being used and analyze how energy is used in your facility. Then you'll benchmark those energy use metrics with similar facilities, or you can also, the best way to always initiate do benchmarks or comparisons with year to year at your own facility as well. Based on that analysis, you can identify and pinpoint energy saving opportunities, but for that you might need a little bit more data or data from sub-meters at the process level or the equipment level as well. And again, this relates to different levels of energy audit. We'll talk about it in just a moment. And then based on that, you prioritize and use data to make informed upgrade decisions. So what are some benefits of energy audits? They obviously give you cost savings and reduce operational expenses through improved efficiency. And the best thing I find about energy audits is like performance tracking. You can benchmark using kilowatt hour, again, this same metric, and see like how you're performing from month to month basis or from year to year basis as well. And this helps you like in guiding future upgrades because you are doing all the inventory of your equipment, see what their energy use is or what their power demand is and how much energy they are using. And this also helps you in guiding future upgrades and justifying funding requests if you are applying for any funding or loan opportunity as well. Time for another poll. Sorry guys, we have a lot of polls today, not much, but initially we have few.
I'll give it another 15 seconds. Okay. So for the question of, has your facility conducted a formal energy audit in the past 5 years? 21% said yes, 41% said no, and 37% are not sure.
Okay. Yeah, I think if you haven't done any energy audit, I'll share some resources in a moment to see where you can get one for free or at a low cost. So that'd be helpful for you guys. Again, if you are unsure what energy audit is or where to start, you have to understand if you're doing you can do it self-assessment or you can do it through third party as well. You have to first start by doing or understanding your energy bill, and in just second, regardless of these levels, there are like different processes that remain same. And you have to start by working with the utility to getting to understand and know your bills, and then go on from there. Document your facility processes, what kind of wastewater treatment plant process that you are using, map your flows, or at least document those numbers and requirements of your permits and major equipment specifications like their power demand or power charges. And then if you have an asset management plan, you might have an inventory of equipments as well. You will be using all your equipments and their significant energy uses as well, with technical specification that can come from, again, asset management plan. And then assess inefficiencies. If they are consuming a lot of power, you can do it manually, or as well as apply some sub meters as well. And then identify outdated equipment, some poor controls or process bottlenecks as well. We'll talk in detail about some process bottlenecks in some of the case studies and how did they identify through the energy audit. I was just telling you about different types of energy audits. The basic one is just self-assessment, which you can do by using your energy bill and using freely available online tools or using an Excel sheet. And then there are different levels of energy audit as defined by ASHRAE, which are ASHRAE level 1, which is walkthrough survey with basic measurements. ASHRAE level 2 is detailed assessment by process equipment, and ASHRAE level 3, which is investment grade in-depth engineering analysis. So what it does, it provides you all these energy conservation or energy efficiency measures for your wastewater treatment plant. And it also lists down what's the return of investment, what would be the payback period, if you should do it in the short term, long term, like these kind of things. I'll show you one of the screenshots as well from a energy audit in the case studies. So this is very helpful to identify when to do and what to do in terms of energy efficiency at your plant. So these are the energy audit tasks defined by ASHRAE. You will collect and analyze historical energy consumption data. This involves gathering and scrutinizing past utility bills and any other records of electricity, natural gas, and energy sources used by the wastewater treatment plant. You will study the wastewater treatment plant process and operational characteristics. This can include a detailed examination of each stage of the treatment process, equipment specifications, operating schedules, and the flow rates that are coming into the plant as well. And then you'll be able to identify potential modifications to reduce energy consumption and cost. Because you are getting a lot of data, you will be able to identify or pinpoint areas where energy use can be decreased, such as we all saw in the poll as well, that optimizing aeration control can be a big energy saver as well, or upgrading pumps and blowers, improving sludge dewatering, or exploring renewable energy integration as well. And then you'll be performing the engineering analysis of the modifications, like evaluating technical feasibility, how easy is to fix that equipment, or how easy is to make that change, and the energy saving potential of it, cost of implementation, and return on investment or payback period of that modification. And then you'll be ranking those energy efficiency measures, as well as preparing a comprehensive report documenting the analysis and process, as well as findings, and showing it to your stakeholders or your plant team to see which way to go forward with. Benchmarking your facilities energy performance, you'll be using, again, standard metrics. I won't spend much time on this. Tracking frequency, and this is really important to see how you are tracking your energy use, and this helps you in identify seasonal patterns, as well as immediately spot abnormal consumptions. If there is any a month-to-month basis, if the flow remains same, and if the energy consumption is going or jumping higher, you can it's demands to have a deeper look into it. And then cost monitoring, because energy is always associated with the high cost. You have to you can track both total facility energy cost as well as process level energy consumption as well, and breaking down usage by process, which can help you in greater insights as well. These are some really amazing energy audit tools if you are doing it on your own. So the first one is EPA Energy Use Assessment Tool. This is a free Excel-based tool for your utility bill analysis and equipment review. It already comes up with few of the equipments which are used in wastewater treatment plants. What you can do is take your utility bill and if you have an asset management plan, you can also take those specs from that asset management plan and put those into this Excel, and can give you like different energy use assessment metrics. And this is freely available. There's a lot of really good guidance available on that as well. The other tool is this is also from EPA. This is called Energy Star Portfolio Manager. This is an online benchmarking tool to compare against similar facilities, just to see how you are doing against other similar facilities, or even like if you just want to compare your own month to month or year to year energy use, you do it using this tool. And this is really easy. You can get used to using this tool in an hour. EPA has a really good webinar on this as well. You just need to input your energy data and your flow data into this Energy Start Portfolio Manager. And the other two tools is Wastewater Energy Management Toolkit and SADA Toolkit. They are collection of resources, best practices, and innovative approaches for energy management. And they do list down the process of getting an energy audit for a wastewater treatment plant as well. Yeah, if you are facing hurdles in getting a professional energy audit, Industrial Assessment Center is a really good resource for that. This is funded by Department of Energy, and it funds different universities and all around the US for offering free comprehensive energy audits. This program was initially designed for small manufacturing companies, but water and wastewater treatment plants are also eligible for this energy audit through this program. So do reach out to them if you qualify for it. And the second best thing here is utility partnerships. Many utilities offer subsidized or free energy assessments as part of their demand side management program. So do talk to your utility if they have any program or any incentive or any low cost incentive available to do this energy audit as well. And then there are some there's some private energy service companies. They often provide preliminary audits at reduced cost as part of their performance contracting. And then there is another government program called USDA funding for third-party energy assessment. This program has been running since last 10-12 years, and we are hopeful that this will continue to run this year as well. The application is usually open in the fall, in July or August, if I'm not wrong, and they are open for a few months. And then you can also get your energy assessment done through this program as well. Energy management plan, I would just like to mention this here. It is important to have an energy management plan, and you can start by establishing an organizational commitment, getting and establishing a team. It can be your plant operator, your facility management guy, and develop a baseline of the facility's energy use. Develop profiles. Again, this will all relates to energy audit. Identify and assess project opportunities once you have the energy audit, and then prioritize those opportunities for implementation. And the main thing is to track and report progress, which is really important to see if there are any sudden changes in your energy use as well. And then I think the major component of this is this all energy management plan is energy data management. You have to define the boundary of your wastewater treatment plant if you are only considering the wastewater treatment processes in your energy audit or energy management, or you are also considering the buildings attached to your facility as well. You then have to establish a baseline. It could be any unit, it could be a year, it could be a month from where you would like to compare your energy use, and then determine a metric. It could be as I told you, million gallons, kilowatt hours of energy used per million gallons per day. and then assemble data and apply conversions and set up a tracking system, which is really important to see how your facility is performing over the years. So energy efficiency strategies, the goal today is to get you familiarized with energy efficiency strategies for wastewater treatment plant. We'll explore some practical approaches to the implementation that can help your facility reduce energy consumption while maintaining or improving operational performance. So the first one is I wanted to address the elephant in the room, which is optimizing aeration systems. We can first start by doing real-time oxygen monitoring. A lot of systems have already installed sensors connected with IoT systems to match blower operations with actual oxygen demand. So what the sensor does is like it measures what the actual oxygen demand is and then prevents energy waste from over aviation. And then there are some diffuser upgrades as well. You can do replace coarse bubble with fine bubble diffusers to reduce energy consumption, which can reach to almost 30 to 50%. And it also improves oxygen transfer efficiency as well. Then this also connects to real-time oxygen monitoring, like aeration optimization, connecting your automated DO control systems with the diffuser and reduce blower energy use by 10 to 15% with really slight investment and no impact on the treatment quality. We'll talk a little bit more in like how and why fine bubble diffusers are really efficient in the next slides. High efficiency blower technologies, I have most of the slides have links attached to it. So if you want to go into a more detail or depth of any topic, you can just click on that and go into more detail into it. So turbo blowers, they are modern high-speed blowers, advanced bearings which reduce losses and oil lubrication requirements, and they can deliver 20 to 40% of energy saving like compared to conventional blowers. And then there is another type of multi-stage centrifugal blowers as well. They are really great in minimizing turbulence and energy losses throughout the compression cycle. I saw one of the case studies that I have mentioned here, which was replacing conventional blowers with turbo units, and they saw like a 30% less energy consumption, and the payback period of that project was 4 years, which is a really good. Equipment upgrade opportunities. A lot of wastewater treatment plants or a lot of facilities are struggling with old infrastructure. So I have listed like equipment type and their typical useful life. And it is important to like, obviously one cannot invest in like replacing a new equipment, but if your equipment is reaching end of the life, it is important to consider like to replace it with a high efficiency motor or a high efficiency pump and install variable frequency drives on the pumps and blowers to match the output, match with the actual demand, and reduce your energy use by 20 to 50%. Again, depends on where you are located, what's your load variability, and what are the cycles of running that equipment. It is really important to right size your pumping systems. Some of them are usually oversized, so if it is reaching end of your life, end of their life, you can you can replace with the right size pumping equipment, and with again VFDs for maximum operational efficiency. LED lighting retrofits. This is the like low hanging fruit, I would say. You can convert to LED lighting throughout your facility to reduce your lighting energy consumption, because this is also one of the major energy users in your facility as well, and get your energy use and the lighting reduced by 90%. And you can also have motion sensors, which are pretty low cost nowadays in low traffic areas for additional savings. I was talking about like high efficiency blowers. Like we can see that fine air bubble systems blower with high efficiency blower, it provides you an oxygen transfer rate of 6.6, which is higher than all other aeration systems, which is really great in achieving the energy efficiency. And another thing I was talking about was upgrading equipments at the end of life. So it is really important to look into the life cycle cost of a pump because or any equipment in general, because you should buy the most energy efficient pump possible, because it might have a lower initial cost, but if it's not energy efficient, it is going to cost you a lot more during its life cycle. So it is important to do the comparison if you are struggling to choose between the two. It is important to do the comparison of the life cycle cost and see which equipment cost you more over the long lifetime. Some simple process control improvements, I've already mentioned a little bit about them. SCADA implementation, these are control and data acquisition systems to provide operators with real-time visibility into the plant performance. And then submetering it can be as detailed as like individual equipment level. Throughout the facility, it can track energy consumption and provide you data insights of inefficient equipment and processes, creating a roadmap for targeted improvements. And then this is automated control systems. This might be a little costly, but this is like advanced, sophisticated systems. They give you like reduce your manual adjustment and prevent human error and intervention and ensure consistent treatment efficiencies. You can use SCADA for energy monitoring as well. It can help you in data collection, analysis, optimization, like implement automated controls strategies that as we mentioned before, and that maintain treatment performance while minimizing your energy use. And this is really great tool for like verification, track and document energy savings, and reporting requirements as well. UV systems are really cost effective for small systems over the 7 years over chlorination and dechlorination. So EPA does recommend if you have a chlorination system, you might want to like think about switching to UV disinfection because this is the most cost effective method. As well, it also eliminates safety risk from storing chlorine gas and use high efficiency bulbs to minimize energy consumption for your UV as well. And also alkalinity management, you can optimize gentrification and reduce or eliminate the need of added alkalinity. Heat pump for facility buildings. Heat pumps transfer heat between the spaces. For example, there are two types of heat pumps: air source heat pump, which exchange heat with the air, and geothermal heat pumps, which exchange heat with the ground. I have shown the picture just to show you how they work, and they function at higher efficiencies than conventional space conditioning equipment and provide the same level of conditioning but use really less energy, almost 3 times less. So these are some cost savings. I have again linked that study here. If you are using any delivered fuel at your home, because this shows for home because buildings are usually like considered as homes for some places. So you can save almost $3,000 if in some part of the country, and also if you are having electric resistance homes or systems at your facility, you can also save almost $3,000 in some parts of the country, or $2,000 per year in other parts of the country. So this is a really great heating and cooling equipment for your facility if you are using one. And then last but not the least is renewable energy integration. If you are having an anaerobic digester, you can convert wastewater sludge into a methane-rich biogas that can fuel combined heat and power systems. They have different efficiency, but it can be a little costly to install. So if you are producing enough biogas, you can convert it into a combined heat and power unit. And solar photovoltaic arrays, they are really great if you're in open land or roof, which is ideal for solar installations. And you can have ground mount solar, which can give you a lot of energy flexibility, I would say, or energy independence. You can get 1,000 to 13,000, 13,000 to 1,300 kilowatt hours per kilowatt installed, depending on where you are located in the country. The lifespan is usually 20 to 25 years with really minimal maintenance, and the cost is $2,000 to $3,000 per kilowatt, again, depending on where you're located or what kind of system you are installing. And this is really great system to have to make your facility a resilient facility as well. And there are a lot of really good incentives available for installing solar from local, state, and federal government as well. Available funding sources, we have a lot of federal programs and as well as state programs. There's always like Clean Water State Revolving Fund. If you are looking to make a big upgrade, you can apply for low interest loans for energy efficiency upgrades. for solar and other energy efficiency and other energy efficiency things like heat pumps. You can tap into Inflation Reduction Act direct pay mechanisms, which is uh, for renewable energy projects, and these credits can cover up to 30% of the qualified expenditures. From what I have heard, this program is going to continue in future as well. And then again, the best way is to like start talking with your utility. Many utilities and states offer custom incentives for large energy users like wastewater treatment plants. And if you are going into the private market, there are performance contracts, which are known as energy saving performance contracts, which allow facilities to implement upgrades with no upfront capital, and you pay how much you save from your these upgrades. Implementation roadmap, you have to start with benchmarking, establish your baseline metrics, and identify key improvement areas through an energy audit. And then the best way to is to like try to get no cost energy audit or low cost energy audits through industrial assessment center, utility programs, or REAP, and then implement based on those energy audits. Implement strategically, balance um, quick wins like LED equipments with long-term pump replacement equipments for sustained savings. So I was telling you about like different projects can have different payback period or return on investment. So LED lighting is like really quick, typical payback period of 1 to 5 years. You can save up to $3,000 per year, and it has a really quick return of investment. If you compare it with other turbo blowers, which are a little bit costly, but it can give you major savings. And I I showed you in a study previously as well that turbo blower replacement was paid back in like 4 years. So it can be again varies from facility to facility, but can be really useful to see and identify which is your greatest need in the short term and the long term. And if this is just a simple payback period, you divide the initial cost by the annual energy savings, and you get the payback period. Solar PV, they have a payback period of 7 to 15 years. Again, depending on how bigger solar you are installing, you can save 50 to 90% of your electric bill, and grants and tax credit can significantly reduce your upfront cost. Yay, time for poll.
Okay, watching poll now. I give it another 10 seconds. Okay. So, for the question, what is the biggest barrier preventing your facility from implementing more energy efficiency measures? 63%, which is majority, obviously, say lack of capital funding. 14% say lack of staff time and resources or resources. 7% said lack of information or expertise. 9% say uncertainty about the return on investment, and 7% say other or unsure.
Okay, great. Thanks. Yeah, cost is always the biggest barrier. So I hope the resources I shared just now will be helpful for you in some way. And if you need any further assistance or technical assistance, you can reach out to us to identify any funding opportunity for you. Okay, time for success stories. So a town of Crested Butte, they had done an energy audit. Did I lose the access? Hey, Owen, can you still see my slides?
I am unable to, and I am running into an
Oh,
issue where I cannot
oh no
get
worries, we
this
can
to.
give it a minute
I,
to it.
give me 1 second. I'm gonna try
Yeah,
something
sure.
quick. There you go. Try relaunching. Okay, we're back.
Perfect. Yeah, so Town of Crested Butte, they did a comprehensive energy audit through a government program to identify low and no cost energy efficiency opportunities. And what they found was the key actions that were recommended through the detailed energy audit was that replace non-functional DO sensors and integrate with VFDs for better control, address excessive inflow and infiltration during the snow melt season because this was in a small mountain community. This was really important as well. And then there are some recommendations I have made it bold to like replace aging surface aerator with more efficient model. We also discussed that, deactivate one UV bank and optimize or make it more energy efficient bulb replacement practices and improve sludge transfer system to minimize lower operation time. Again, we talked about all of this a little bit, and they have also been recommended to do or make these changes at their facility. Um, so this is also again linked and the source is provided here as well. You can go into this document and see they have some short-term which are indicated as ST, and they have some long-term measures or recommendations as well, which are related to aeration, oxidation ditch, UV disinfection, solid handling, and then they also have savings listed along with that uh, per year and like percentage of it as well. And then they have like some next steps on conducting a study, benchmarking using EPA portfolio manager, and develop an energy management plan as well. So this can be really useful for you if you are thinking of doing any energy audited facility and what kind of actions or what kind of savings you can like have. Another wastewater treatment plant in Tennessee, a no-cost operational change. So what they found through their energy assessment was that second digester aeration was unnecessarily full-time, and they reduced it from 24 hours to 6 hours a day. And then the aeration operation was manually adjusted. They didn't even install any like sophisticated sensors or EFTs. And they got savings, a lot of savings in like energy, which were almost $85,000, 85,000 kilowatt hours per year, and they reduced 11% of peak demand as well. And in future, they were thinking to install timers for automated aerator control and further improvements. And other wastewater treatment plant from Alabama, they reduce high energy use from aeration again through low cost operational optimization. They reduced or adjusted operations to run two of their 12 aerators plus two mixers for 18 hours a day. They introduce anoxic conditions for 4 to 6 hours a day by lowering dissolved oxygen set points, which can really help in reducing their energy use. And they saved almost $70,000 in that year, and then also reduce carbon emissions and effluent nitrogen reduction as well. So this is again also linked as well if you want to go into more detail. City of Flagstaff water system, they were recommended to replace inefficient pumps, blowers, and boosters, monitor their power use and demand charges in real time by installing submeters. Or if you just go talk to your utility, they have the meters nowadays, they have great data capability. They can give you a 15-minute interval data of your facility as well, improve, and they thought to improve staff training on energy efficiency and rate structures, and they made a lot of energy savings of $347,000 with a payback period of 2.47. And they saved by installing blowers and saved almost $100,000 per year by increasing efficiency from 35 to 40% to almost 70%. So what are the next steps? We'll just briefly talk about it. Yeah, again, the best practice is to start with a comprehensive energy audit or a self-assessment as well to benchmark current usage and identify the highest impact opportunities. Then aggressively pursue financial incentives, because this is really we saw the priority of almost all the people in this webinar, and you can go for utility rebates. There are a lot of utilities, they are offering a lot of rebates. Even the state governments and local governments are offering a lot of rebates for energy efficiency upgrades. So you can go reach out to them and see what kind of rebates are available, what kind of grants. Some of the states also have energy efficiency upgrade grants or renewable energy integration grant for a facility as well. So that can be really helpful in becoming energy independent. And then there are some loan programs as well that can cover up to 30 to 50% of implementations cost. You should focus on high impact systems, prioritize aerations, motors, drives, and process controls, which typically represent largest energy consumers, and then again develop a culture of efficiency by integrating energy management into your routine tasks in operations and decisions at all levels of the organization. So as we talked, like if you are thinking to replace an equipment, just think in the terms of efficiency or energy efficiency, see what the cost would be over the life cycle of that equipment, and then make a decision to replace that equipment. Implementation steps, again, similar stuff. Conduct initial assessment, use an EPA tool to identify your facility's biggest energy users, develop a funding strategy, talk to the people, see what kind of incentives are available. I'll show you a database as well in a moment, and implement and monitor. This is really good or good thing to have or do, because you can begin with quick win projects like LED replacements at your facility, and then use those savings to plan long-term improvements by replacing equipment through those savings as well. And you can obviously install sub-metering to track specific process energy use and verify the savings from implemented measures. These are some really great resources I have linked here. Energy Best Practices Guide. It provides information and resources to assist water, wastewater facility management and staff in identifying, implementing opportunities to reduce energy use. And the other one is specifically mostly for small wastewater systems as well. It provides practical guidance for small wastewater treatment plants on tracking and managing energy performance to support cost-saving energy management programs. This is a really great resource. It provides process level energy efficiency measures from equipment replacement, operational improvements with reasonable payback periods. So it lists down for each process what kind of energy conservation measure can be done, what could be a payback period. The only caveat is that it's a little bit old, but again, the mechanism still remains the same. You can get a sense of like how much energy you can save, or what could be the traditional payback period as well, because cost of energy have also increased over the years as well. And it focuses on both established and innovative energy conservation measures as well, and includes case studies of wastewater treatment plants or facilities that have already implemented that, and their cost savings as well. I was telling you about Portfolio Manager. I recently did this for a wastewater treatment plant. So what is required for this is like monthly energy use for all fuels. For example, if you are using natural gas for heating, you can input that as well as your electricity data, and that can come directly from your energy bill. And then average daily influent flow, which I assume would be monitoring energy PD or million gallons per day, and then plant data like building square footage. This is like just really basic terms which we all might have access to. Average influent BOD, average effluent BOD, plant design flow rate, and if you have a trickle filtration process, yes or no. If you have a nutrient removal process, yes or no. And then based on that, it creates a metrics summary. This is like pretty basic. It can go into a little more detail as well, depending on what you want to see. As I've shown here is like energy baseline was established for December 27. I'm comparing it with December 2021, and you can see that the plant has reduced their energy use by 13%. We can see that the energy use efficient intensity is kilo BTU per gallons per day, and if you convert it into a kilowatt hour per million gallon per day, it's roughly translates to almost 3,600 kilowatt hour per million gallon per day, and now it has reduced to 3,100 kilowatt hour per million gallon per day with an efficient, like reduced energy use of almost 14%. So this is a really great tool to see how your facility is doing over the years and monitor your energy use. And this is an amazing database of state incentives for renewables and efficiency, and it lists down all the incentives, even your local government incentives as well, if there are any. So if you just click on your state and see, like, it'll list down all the incentives or policies that are available to take advantage of, or any rebates that are available within your territory. So you can just click on this and it'll list down all your rebates, incentives, and sometimes grant opportunities as well, which are mostly recurring. So yeah, and this is again linked as well. So you can go back, click on this slide and go to that resource. And most of the resources have tried to link or to a suitable like websites where you can review more. That's all from my side. So if you have any further questions, you can reach out to me via email, or we can have some questions now as well if we have any in the chat.
Yeah, we do have some questions. We also had one last poll question. I don't know if we wanted to run that.
Yeah, sure. Please go ahead.
Okay.
Sorry, I kind of missed that.
No worries. I'll take this opportunity to say too, if anybody does have any questions, feel free to add it in the question dialog box when we're finished with this poll. Give it another 10 seconds. Okay, so the poll question says, which energy saving solution have you implemented or are considering implementing? 36% said optimizing aeration systems, 10% said upgrading pumps and motors, 19% said implementing better process control / SCADA, 12% said switching to LED lighting, and 24% said exploring renewable energy options.
That's great. Yeah, we recently did a webinar on solar for wastewater treatment plants as well. So if you go on our website, you can also have a look into that if you are interested in exploring renewable energy options for your facility, or you can reach out to us as well if you have any questions.
Okay, so we can jump into the questions that did come in. We only have one. Someone sent in saying, you listed REAP program audits, but to their understanding, REAP is only available for is only available for profit entities. What REAP programs are available for nonprofits and governmental entities?
Yeah, so I was, as far as I know, that program was available for the nonprofit and public entities as well. But if not, you can definitely reach out to that industrial assessment centers, and they have, like, if you meet the requirement criteria, which is based on like energy use and staff, you can reach out to them, and they are like spread all across the US through different universities, and you can definitely reach out to them for a free energy audit, depending on where you are located and which university is assigned for your location.
Fantastic. Are there any other questions anyone have? I'll give it a minute just to see if anything comes in. Okay, I'm not seeing anything, so I think we're good.
Thank you, Owen, for doing all these polls and webinar and being there.
Yeah, of course, no worries. So to wrap up, a huge thank you to Dinesh for sharing their expertise with us today. Following this webinar, you will receive a follow-up email with the slides from today and a link to the recording. We also ask that you complete the webinar evaluation following the webinar so that you can let us know about your thoughts on today's session, as it will help us plan for future webinars on topics that are important to you. Thank you again, and we hope to see you at future EFCN events.
Thank you. Have a good day, everyone.